Hello everyone, I am Siri studying at Sri Venkateswara College of Engineering, 3rd SEM, CSC branch. Now I'll be discussing about maths. In maths, the Anova in mathematics is the concept. Introduction to Anova in mathematics. Analysis of variance, that is Anova, is a statistical method used to analyze the differences between group means. ANOVA is commonly used in experimental research to determine if there are significant differences between multiple groups. The real goal of ANOVA is to partition to the total variance into different sources to understand the variability within the between groups. This is all about introduction to ANOVA in mathematics. The next is types of ANOVA. There are three types of ANOVA. They are one-way ANOVA, two-way ANOVA, and that last factorial ANOVA. One-way ANOVA used when there is one categorical independent variable with more than two levels. Two-way ANOVA involves two independent variables and examines how they interact with each other. Factorial ANOVA analyzes the effects of multiple independent variables on the dependent variable. Assumptions of ANOVA: independence, normality, and last homogeneity of variance. Independence. Observations are independent of each other within and between groups. Normality. The residuals of the model should be normally distributed. Homogeneity of variance. The variance within each group should be approximately equal. These are the assumptions of ANOVA. The next is null hypothesis in ANOVA. The null hypothesis in ANOVA states that there are no significant differences between the group means. If the p-value is less than the chosen significance value, that is usually 0.05, the null hypothesis is rejected. Rejection of the null hypothesis indicates that at least one group mean is significantly different from the others. This is about the null hypothesis in ANOVA. The next is calculating ANOVA. ANOVA calculates the F statistic by comparing the variance between groups to the variance within groups. The F statistic follows an F distribution, and the p-value is used to determine the statistical significance. Software programs like SPSS or R can be used to conduct ANOVA analysis efficiently. This is about how to calculating the ANOVA. The next is post hoc tests in ANOVA. Post hoc tests are used after rejecting the null hypothesis in ANOVA to determine which specific groups differ significantly. Common post hoc tests include Tukey's HST, Bonferroni, and SCAF tests. Post hoc tests help avoid type 1 errors that may occur when conducting multiple pairwise comparisons. This is about the post hoc tests in ANOVA. The next is effect size in ANOVA. Effect size measures the strength of the relationship between the independent and dependent variables, as I said before. Common effect size measures in ANOVA include eta square, that is n square, and omega square, that is omega square. Interpreting effect sizes helps researchers understand the practical significance of their findings. This is the effect size of ANOVA. The advantages of ANOVA. ANOVA allows for the comparison of multiple groups simultaneously, saving time and resources. It provides a comprehensive analysis of group differences and interactions between independent variables. Anova can handle both categorical and continuous independent variables in the analysis. These are the advantages of Anova. Limitations of ANOVA, that is disadvantages. ANOVA assumes that the data meet the underlying assumptions of the model. It may not be suitable for some small sample sizes or non-normally distributed data. ANOVA does not provide information on the direction or strength of relationships between variables. These are the limitations of ANOVA. Real world applications of ANOVA. ANOVA is widely used in scientific research, including psychology, biology, and social sciences. It is used in quality control to compare the means of multiple samples in manufacturing processes. ANOVA is also applied in market research to analyze consumer preferences across different demographic groups. At last, the conclusion. ANOVA is a powerful statistical tool for comparing group means and understanding variability in data. By partitioning the variance into different sources, ANOVA helps researchers draw meaningful conclusions from their data. Understanding the assumptions, calculations, and interpretation of ANOVA is essential for conducting accurate statistical analysis. Thank you.